At the summer trip equations. So oftentimes when we're looking for solutions, we're looking for the solution that happens between two of the graphs. So for the summer trip, we have the first line and it's bounding everything below it. Then you have your second line and it bounds everything above it. So our solutions are coming from the region in between, meaning that anything in between those two lines where the darker overlapped shading are points that could be solutions. And then the baking, there were 3 equations that went with the baking: the max number of cupcakes, max number of cookies, and then the combinations of cupcakes and cookies, as well as needing to bake 3 times as many cupcakes as cookies. So I gave you a combination of 4 equations. That put your graph down there in the corner. So all combinations come from any of these points in the darker shaded region. Okay. So what I want to do with you today is look at more graphing absolute value inequalities with inequalities. So we are on our last day of this packet. We are looking at the practice handout. So we're going to pick up with the 3-3 skills practice, graphing systems of inequalities. We're going to continue to review these over the next few days. And on Friday, we will have our Chapter 3 test, which means next Monday we will start Chapter 5. So in number 1, you have an X and a Y only. That's going to create 2 lines, one that's horizontal and one's that's vertical. So y being greater than or equal to -1 is going to be a horizontal line. You're going to shade above that horizontal line. And again, like I've said in the past, you want to keep your shading of the first line lighter. For the second line, it is dashed and straight up and down. And then this line is x values less than 1. So you're going to double your shading and overlap that top corner. So where your shading is the darkest are where your solutions come from. A solution cannot come from the dashed line because the points on that line are not included. An example of a solution, though, could be anywhere in that purple region, including on the line y greater than or equal to -1. So you could have the point -2, -1, or you could have a point up in here, or you could have a point over there, but you cannot have a point when x is 1. That's the only point you cannot have in that shaded region. Okay? Let's look down at number 4. You have y greater than or equal to x. That goes through our origin. It's going up 1 and over 1. It's greater than or equal to, so my line is solid. And y's are greater, so you shade above. The second line also goes through the origin. It's also equal to, but now my slope is negative, so it is the reflection. So I got a 50-50 shot at this point. This area is either going to be above the line or below the line. The y values have to be greater than -x. So they're going to be above, so you're shading the top triangular region. Now, solutions can come from both on the line and in the shaded region. So 0, 0 is the point of intersection of the two lines and a solution. 0, 5 up here would be a solution. And any points on the line would be a solution. So 2, 2, negative 2, 2, etc. So if I ask you to identify a solution, there are many, many possible solutions. You just have to make sure they meet all of their requirements. So for today, you are doing the 3-3 skills practice. Tomorrow you're doing the 3-3 practice. And then we will go over all of that on Thursday. So make sure your packets have both of those. And we'll go over everything on Thursday. What?
What one's the dashed line?
Dashed is if there's no equals to. So like if you look at example 2, they're both solid. But in example 3, the x greater than 4 will be dashed because there is not an equal to on my inequality. So the equals makes it solid. It's saying it has to be greater than and it can be equal to. So if it's just greater than, it's like getting really, really close to that line but never actually getting a solution from the line. So that's why we make it dashed.